Okay, this is Mr. Asher, and I'm going to walk through some problems on dimensional analysis and changing units. And I just want to remind you some basics about changing units. And it's all going to be based on the concept of an equivalence statement. So for example, an example of equivalence statement would be 1 inch. 1 inch is equal to 2.54 centimeters. And what this means is sort of a philosophical thing where what we're saying is there's a physical dimension of length that's maybe an inch there. And so we call that 1 inch. And in terms of space, that is the same dimension as 2.54 centimeters. So that these two things are equivalent. That's what we mean by that equivalence statement. It's the same physical quantity. And so we can use this equivalence statement to convert length in inches into length in centimeters, or length in centimeters into length in inches, because we can imagine the problem as being something like this, that if I want to figure out if I want to figure out, say, how many eighths of an inch 3/2 is, right? Well, I can figure out how many eighths of an inch that is by multiplying this by 4/4, right? And what happens then is that this becomes 12/8 because each of these things multiplies straight across. And so I've converted now 3/2 into 4/4. The idea being that 4/4 equals 1. So that's an identity operator. So I can always multiply anything I want by 1, and I get the same thing. So these unit conversions are going to work the same way, where we're going to multiply things by 1. Okay, so this is our conversion factor. And let's say we want to convert 8.25 centimeters, and over here we want inches. Okay. Well, we need to multiply this by something that has the value of 1, but has the units of inches and then centimeters. And what's going to happen is we're going to say that centimeters is on the top and the bottom, and those units cancel, but now we need numerical coefficients in here that will be 1, that will make this part here be equal to 1, so we can multiply it by 825 and not change the physical dimension. And to do that, we would say, well, from our equivalence statement, the dimension on 1, which makes this equivalent, is 1, and then 2.54, right? Because this being equal to this means that if I divide this by that, it's 1. It's just the same thing if I say A equals B, then A over B is equal to 1. Okay? So now that I have centimeters canceled, I just have to take 8.25 and divide it by 2.54, paying attention to significant digits. 8.25, 2.54, and I get 3.25 inches. So 8.25 centimeters is 3.25 inches. Right? Okay. And I can go the other way. If I have 9.81 inches, then I have to have a conversion factor that is centimeters per inch. And if this was 1, if 1 inch over 2.54 centimeters is equal to 1, then 2.54 centimeters over 1 inch is also equal to 1. And now inches are canceling. And if I multiply 9.81 by 2.54, I get 24.9 centimeters. Okay. So that's the whole basis of this. The idea here is that we're taking a number that has units or dimensions, So it could be, let's say we're converting alien current, well, no, that's a bad idea. Well, let's say we're converting grams into kilograms, okay? So we know that 1,000 grams is equal to 1 kilogram. And let's say we want to convert 8.52 times 10 to the fourth grams into kilograms. Well, then we're going to have something here with units of kilograms over gram, because then grams will cancel in the numerator and denominator. And I need to have a numerical coefficient for kilograms, which is 1 in the top, and a numerical coefficient for grams in the bottom. And I'm going to rewrite that 1,000 as 10 to the third grams. So 10 to the third, right? And this comes out to be, because grams is canceled, 8.52 times 10 to the fourth over 10 to the third kilograms, which is equal to 8.52 times 10 to the fourth. And I can bring this from the denominator, from the bottom up to the top, by changing the sign, times 10 to the minus 3 kilograms, which is equal to 8.52 times 10 to the first kilograms, or in standard notation, 85.2 kilograms. Okay, so all unit conversions are going to be done using this technique, right? So we can just work through some, and for a couple of these here, I might have to go look up coefficients that I don't really know off the top of my head. But let's see here. Okay, here's a good one. Let's convert the mass of a 5.00 grain aspirin tablet. And a grain is a pharmaceutical measurement of mass, and it turns out 1 grain. Oh, we want to convert that mass to milligrams, which is mg. So 1 grain, oh, that's really ugly. 1 grain is equal to 0.00229 ounces, right? And now I have to look up the conversion between ounces and grams, because I don't know that off the top of my head. So let me look that up. I think there's a conversion table in my book, but I just have to get it here. Just call it up. Yeah, here we go. And 1 ounce is equal to 28.349 grams. And this is ounce OZ avoirdupois. I think that's how you pronounce it. Avoirdupois, which is our common ounces we use, as opposed to troy ounces, which is what they measure gold in, which are a bit larger. But we're going to do avoirdupois. So these are 1 ounces, 28.39. And the final we need is that 1 gram is equal to 1,000 milligrams, or 10 to the third milligrams. Whoops, 10 to the third milligrams. Okay. So now I could say, okay, so I've got 5.00 grain aspirin tablet. And now I'm going to convert between ounces and grains. And then I'm going to convert between grams and ounces. and then I'm going to convert between milligrams and grams. And you see what happens is by chaining these together, I've got grains canceling grains here, and ounces cancel ounces here, and grams cancel grams here, leaving me with milligrams, which is the unit I want. And now it's up to me to go ahead and plug in all of these different things. So 1 grain is 0.00229 ounces, and these numbers come from my equivalent statement here. And then I've got 1 ounce is equal to 28.349 grams. And then I've got 10 to the third milligrams is equal to 1 gram. So now I just have to multiply all of this out. So it's going to be 5.00 times 0.00229 times 28.349 times 10 to the third milligrams. I'm just going to multiply that out. 5.00229 times 28.349 times 10 to the third. And this is 3.25 times 10 squared milligrams, or 325 milligrams, which is the size of a common aspirin tablet, 325 milligrams. Okay. All right. I'm sorry. Yeah, 325 milligrams. Right? Right. 325 milligrams. Yeah. Okay. So there's one example of a problem. So let's do another one. Let's convert the mass of a 2.3 ounce egg into grams. Well, again, 1 ounce avoirdupois is equal to 28.349 grams. That's the conversion factor I want. I guess I better check that to make sure I've got that, remember that correctly. Yep, 28.349. Okay, so now I'm going to convert ounces, 2.3 ounces. And then my conversion factor, which again is just a way of writing 1, is 28.349 grams over 1 ounce. And remember, this is just saying that whatever mass this is, it's identical to this. So if I divide this mass by that mass, or if I divide 28.349 grams by 1 ounce, that's equal to unity, 1, because this is the same mass here or here, just expressed in different units. It would be absurd to suggest, it's absurd to say 28.349 over 1 is equal to 1. This is clearly not what we're saying. We're saying here that once we put a unit on here, a dimension, this actually has a physical meaning. It's a defined quantity of mass in the universe, as is this. And what we're doing when we say this, that this over this is equal to 1, that whatever mass this is, it's equal to this mass. And that's what gives us unity. And so these units, these labels here, the dimensions, carry through in our calculations. So when we bring them down here, this thing here is going to cancel out this thing here, right? So that when I multiply that through 2.3 times, excuse me, I come up with 65 grams, or in scientific notation, 6.5 times 10 to the first, where there are 2 digits of precision here because I only have 2 digits of precision there, right? So I wouldn't carry that out any farther, even though I know my conversion factor to 5 digits, okay? All right, I'm going to do one more, and hopefully you're getting the hang of this. Let's see, where's a good one? Oh, here we go. All right, so this is, there was uh, a rally driver, and they completed a race with an average speed of 229.8 kilometers per hour. And we're going to do two conversions. We're going to convert this into miles per hour, and we're also going to convert it into meters per second. And then we'll also convert it into feet per second. Okay, right? So the first thing we want is to go between hours and hours here, to go from kilometers per hour, just thinking about the units, into miles per hour. We need a conversion factor here, which will have units of miles per kilometer, right? And for that, we need an equivalence statement between kilometers and miles. So we'll go back and find our equivalence statement table. And we find that 1 mile is equal to 1.6093 kilometers. Okay. I guess I don't need that anymore. So that this would be 1 up on top, and then 1.6093 kilometers on the bottom. And our value out here is 229.8 kilometers per hour, because that's what we're trying to convert into miles per hour, right? So 229.8 kilometers per hour divided by 1.6093, so 229.8, 1.6093, and I come out with 142.8 miles per hour. Boy, that's very fast. I hope this driver wasn't on an open road. Okay, right? And notice here that I had 4 digits of precision on my starting number, so I made sure that my conversion factor had 5 digits of precision, right? So I have more precision in my conversion factor than I do in the number I'm trying to convert. So I left with 4 digits of precision in my answer, 142 miles per hour, right? Okay. And now I want to convert this into meters per second, okay? So let's start again with 229.8 kilometers per hour. And now there's 2 ways I can approach this. I can say that I want to convert hours into seconds directly. So that would be hours per second, right? And there is 1 hour for 3,600 seconds, right? Now let's say I don't remember that conversion, and then hours cancels hours, leaving me with kilometers per second, right? Oh, they want me to do meters per second. Oh, okay, all right. So I've got it into seconds this way, but there's a second way to convert hours into seconds. 229.8 kilometers per hour. And it absolutely doesn't matter how you do it, you'll get the same number. And the first thing I'm going to do is I'm going to convert hours to minutes, and then I'm going to convert minutes to seconds. So there is 1 hour for 60 minutes, and there is 1 minute for 60 seconds, right? And so hours will cancel hours, and minutes will cancel minutes, leaving with seconds. So this is now equal to 229.8 kilometers Now let me write it there. Times 1 over 60 times 1 over 60. Whoops. 60. I'm not doing so well tonight. 60. And then this is now kilometers per second. And that 1 over 60 times 1 over 60 is 229.8 times 1 over 3600 kilometers per second, which is the same thing I did here by converting directly, right? So it doesn't matter which way you do it. So I'm going to continue on here. So this is 229.8 divided by 3600 kilometers per second, right? And then now I'm going to convert between meters per kilometer. So it's 10 to the third meters per kilometer. Remember that from last time, that 1,000 meters per kilometer per 1 kilometer. So now kilometers are canceling, and I've got meters per second. So this is now 229.8 for 3,600 times, excuse me, 10 to the third is 63.83 meters per second. Okay. And now I'm going to get rid of all of this so I can do my final conversion. Okay. And now I need to convert meters per second into feet per second. So 63.83 meters per second times, and now I need a conversion that is feet per meter. And I have to look that up. Maybe I can find it here. I don't have that. But what I do have is I have a conversion that is, I don't have feet to meters, but what I do have is a conversion that is yards per meter. And then I can remember that I know the conversion factor of feet per yard, right? Because I know that 3 feet is equal to 1 yard. So this is 3 and this is 1. And then the other one is yards per meter, and that's in the textbook, and that's 1 meter is equal to 1.0936 yards. So 1.0936 yards over 1 meter. So meters will cancel meters and yards will cancel yards, leaving me with feet per second. So 63 times 1.0936 times 3, and this is 209.4 feet per second. Okay. And remember, this here, 3 feet per yard, these are exact conversions, so they have arbitrary precision. So my precision is still fixed by the precision I started with. Okay, hopefully this helps you in figuring out how to do these unit conversions. It's really just about canceling out the units so that they don't so that they're gone. And remember to keep track of your conversion factors when you set up your equivalences. All right, I'm going to stop there and I will talk to you later.